Hello, everyone. My name is Stephanie Broxton, and welcome to the Smarter Together webinar series. This webinar series touches upon how multidisciplinary applied research can be used to make a community impact and improve the human condition. Before we begin, I would like to remind all attendees to keep your audio and video muted throughout the duration of the presentation. At the conclusion of this presentation, there will be a short Q&A session with any remaining time. If you have any questions for our presenters, please feel free to put them in the chat box at any time, and I will read them to the presenters at the designated time. At this time, I'd like to welcome Greg McCormick, the director of the Georgia Smart Communities Challenge, to introduce today's presentation.
Thank you so much, Stephanie. It's so great to have you all to join us this afternoon for the Smarter Together webinar series to hear from the city of Valdosta and their project team and their Georgia Tech research team that's been working for the past year on their Georgia Smart project, dealing with emergency vehicle preemption and public safety in transportation space. So we're really excited to hear from their team. There's a number of presenters that we'll be hearing from today. It's going to start out with Pat Collins, who will be presenting a quick video, about a 2-minute video, to show you the technology demonstration in action in downtown Valdosta. So we're really excited to see that. So welcome, Pat and the Valdosta team.
Hello from Valdosta, Georgia, and welcome to everyone. I'd like to thank the Partnership for Inclusive Innovation and Georgia's Tech and Smart Cities for giving us this opportunity. You're watching our fire trucks go through Valdosta, Georgia. We're going to go through 10 intersections with our newly installed emergency vehicle preemption. As you can see here, we are crossing over a section of US 41 and going over another section, and this truck is probably getting out of the way. And we'll probably loop around again. We're going to go up to the next light, and as you see, as the fire truck is coming to the signals that they've already turned green. We're going to turn a left here on Lee Street, and we're going to go down to Central. I do want you to note when we're going down Central that you will see the light turn green again at Ashley, but then down at Patterson, there'll be a truck, another semi-truck. And you'll notice that while these lights are already green as we're approaching, the one down there will still be red. And that's because the technology that we put in is still trying to decide. Here it is right here. Notice it's still red and it just turned green. It was trying to decide whether or not this truck there to our right as we go by was going to turn in front of them or not. So this is emergency vehicle preemption, and we just thought we would try to start you out with a little adrenaline on this wild ride. So anyway, our project team consisted of the city of Valdosta and the traffic manager, Larry Ogden. And of course, we would like to thank our city council for their support in funding the project. Our partner in this city group was the Temple, who provided the equipment and applied information that provided the application that we're using. Also, we had some research done. Most of our presentation today is going to be about research. You will hear from the folks at Georgia Tech and the people from Valdosta State University. Next slide. Next slide, yeah. Next slide. All right, so for a project overview, what we originally wanted to do was we wanted to establish a connected traffic signal system, which is what the GLANCE system does. And we have 128 signals here in the city of Valdosta, and we did this citywide. So all 128 now have preemption. We also activated the Travel Safely application, which is like a Waze app. We also wanted to analyze changes in traffic patterns, as well as the citizens' perception of the Travel Safely application. Do they use it? Do they like it? Let me just say that in the future, This technology will be installed in over 200,000 Ford vehicles, is from what I understand. You won't even have to download the application. We also wanted to provide a unique educational opportunity for both students at Georgia Tech and VSU to do research. And we're starting up a new program over at VSU, but you'll hear more about that. Next. This is the project timeline. We started about a year ago in September of 2020. I've got three different segments on here. The first one at the top shows what the city did. Basically, we installed the preemption and the wire harnesses in the fall of last year. And then over the winter and the spring, we had 3 rounds where we went out and installed the equipment in our traffic cabinets and got everything ready. Then in July, we had an on-site event. You're going to hear more about that. And then today we find ourselves doing the final presentation. Over at Valdosta State, they did student surveys back in the fall. They started their research over the winter and started doing community surveys again, then back in the spring and summer. The interns have been putting things together, and today we're going to hear a little bit about what they found. Also at Georgia Tech, very similar type of track. They did research from information that we had given in years past about responding from our fire department, about responding to incidents. And really what they were looking at is to see how well preemption did with our response times. Next slide. And at the time of the project, we had a lot of community support, and Stan Krantz, who's the Director of Business Recruitment at the Valdosta Lowndes Development Authority, for example, said that receiving the Georgia Smart Communities Award will make it possible for the city of Valdosta to be recognized as a smart city in Southern Georgia. It's going to help attract more industries to the region. It will also help engineering students at VSU to have opportunities to collaborate with the Traffic Management Center. It will make it possible for Georgia Tech to develop further their engineering programs. And with that, we'll go on to the next slide. Now I'm going to introduce Adrian. Adrian Baker is with Temple, and he's the one who provided us the equipment. Adrian.
Good morning, everyone. Thank you for this opportunity. I'm glad to be a part of this team as well. So going through some of the emergency vehicle preemption and travel safely, we'll do that right now. Next slide, please. All right, in May and June, our technicians, as showed on the timeline, went down there and checked controller configurations for all 128 intersections. Preemption and travel safely testing right now, as Pat mentioned, it's downloaded on your phone. There's going to be in the future where a point where cars will have this as an availability. Then you put this in your car and it starts with your startup, will overtake your speakers and give you those notifications in a connected vehicle future. We delivered connectivity and support plans for all of the city for emergency vehicle preemption and the travel safely upgrade. And part of our deliverables, all the units were installed in Valdosta fire truck in a period of about 2 weeks, and they've been operational since June. We conducted driver and engineer training for Valdosta, the fire department drivers as well. All 3 shifts of drivers were trained on this to understand and know what their responsibilities are as approaching these intersections. Firefighters are able to get to the scene much faster as a result, and travel safely for those drivers around that emergency vehicle warns them of potential conflict with an emergency vehicle by letting them know through the Travel Safely app that there is an emergency vehicle around them, and it even gives them a direction that they're approaching from. Next slide, please.
Meet Travel Safely, an app that helps you get where you're going safely. Travel Safely works if you're driving, walking, biking, wheeling, scooting, or skating. Get real-time audio notifications.
Red light.
So you can focus on your surroundings.
Get ready for green.
Travel Safely works with local emergency vehicles, helping them respond to calls faster. Get notified when an emergency vehicle is approaching, or when to share the road with your two-wheeled friends.
Cyclist. Vehicle approaching cyclist.
So whether you're on the road or just crossing,
Pedestrian.
every time you open Travel Safely, you're helping make a better commuting experience for all of us. Download the Travel Safely app today and join our community of users committed to making our roads safer.
What we wanted to show everyone there is all of that footage was done inside the city of Atlanta in the metro area. You guys, Georgia Tech, all of our partners, VSU, all of you guys were an important part of making Valdosta the first fully connected city outside the metro area in the state of Georgia. So that's a big deal. Connecting people, cyclists, intersections, crosswalks to one another, connecting everything to everything. That's what our goal was as a connected vehicle city. And you guys are the first ones you helped us become the first city outside of Atlanta Metro doing that. And so what you see is a little bit of the glance login right there. Those blue lines are some of the tracking of the emergency vehicles as they transit throughout the city. They are doing their job going back and forth. Any sections of orange lines that you see are them actually with the emergency vehicle preemption going on. But it's a very useful tool for engineering and the fire department. Next slide. This is a close-up of just some of the preemption runs, as they're the blue lines are the things that they're just normally transiting to and from fire hydrant checks, school safety events, those kinds of things. The orange is where they implemented the preemption. And you can run that for all your engines or one very specific one for a date, time zone. Next slide. Once intersection, the future plans. Once those intersections are up and running, they are right now, preemption and travel safely. Plan to start promote the new technology through social media and do some more things there. So I've been pulling together some ideas and things we can do to further that. Additional users to be configured, preemption for Lowndes County bus system to get those Lowndes County schools off of the interstate, and as well as the Valdosta City school beacons. So when you drive through a school zone, or a work zone, you're notified on your car or your app on the phone on one of those two ways that you're entering those work zones and to slow down. We want to use Travel Safely to alert PEDs of oncoming motorists, as well as you saw in that part of the video. Use preemption to decrease fire truck response times and decrease chances of accidents at signalized intersections. So we configured, all right, so next slide. Emergency vehicle drivers are going to be able to, as that video shows, it's a little bit stop and start to that. But when you see the actual video, they are moving, just rolling through one intersection after another. And getting green lights makes a real difference to shave about 10 to 11 seconds off of each intersection they go through. Emergency vehicle drivers can get there much faster, even in downtown areas of Atlanta. They went all the way around in a big circle inside downtown Atlanta in that video. Drivers and pedestrians in the area of that EVP call using Travel Safely are notified whether they're on foot or on a skateboard, a bike, in a car, where that emergency vehicle is coming from, connecting everything to everything. Emergency vehicles are not using their brakes as much during emergency calls as well. That's a major thing to slow down a 17-ton engine over and over and over so that that engine can take off again after they get past the intersection. So you save downtime and maintenance. PEDs and cyclists can get the same information as motor vehicles via Travel Safely. That's another current impact. Current impact is drivers are alerted to the cycle length and when signals are about to turn green. So the message "get ready for green" helps them to be with a heads up, to be able to be ready to go when they get that green, instead of the slow start offs that we all are familiar with right now. The Travel Safely app warns drivers of presence of pedestrians and cyclists ahead. connecting everything to everything. Next slide. And drivers and pets will be more aware of events around their vehicle. That's a projected impact we have. Other vehicles, cyclists, pedestrians, and emergency vehicles. Again, connecting everything to everything builds a foundational base for the future and for autonomous vehicles. People have talked about that. We're actually doing that in the city of Valdosta to begin moving us closer to that day. Connecting Valdosta school zone beacons with glance will ensure drivers know they're approaching a school zone and to monitor their speed or slow down. Adding glance school time clocks so that even Valdosta school zones are integrated into TMC and glance in one continuous view. That's a big impact for traffic engineering to see all of their devices in one place instead of these different silos of information in different software packages. This will give them the capability with Travel Safely as shown in the applied information videos. As Travel Safely enables cars to come into a school zone, they'll hear an audible bump, 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 and drivers will hear speeding in school zone through that Travel Safely app, whether it's on the car or on their phone. Transit signal priority for Lowndes County School Bus System and Lowndes County, the high school and other schools that can get them, once they have the device on their buses, can get them off of that long queue that sits on I-75 in that cloverleaf trying to get down to the surface street to get on to school. So that was a particularly dangerous thing, that these school buses, 10 to 12 of them sit out there right beside semis that are going by at 70, 75 miles an hour. And so the idea, the thought is that intersection is ready now. All that's remaining is to put the device on the school bus and they'll be out of the way of traffic and off the interstate. CV2X, the connected vehicle to everything, enables vehicles to talk to all 128 intersections as part of standard factories installed CV2X, which means that at a point in the future, you would no longer have to have it on your phone if you're in your car. Next slide. Okay. With that, we'll turn it over to the Georgia Tech team members.
Thank you, Adrian. This is Babak Ashuri here from the School of Building Construction and Civil and Environmental Engineering. Good to be with you. This was a great opportunity for us to get our students engaged with first-hand data collection, first-hand data analysis, and working with multiple research partners. There were 2 PhD students involved at different stages of this project, Hunjin Oh and Shuqin Zhang. And Aaron Will was undergraduate researcher that worked towards the beginning when we did many of these setup for the data collection. I'll pass it to Hunjin to walk us through some of the analysis that we did.
Thank you, Dr. Ashri. The most important thing when we talk about how to evaluate the performance of a preemption system is emergency response time. Within this emergency response time, our project is focusing on travel time, and upgraded cabinet enables preemption vehicles to save their travel time when they pass the intersection. So we recast the response time data from fire department, and we conducted research based on this response time data. So the research goals and objectives are understanding the data through visualization and propose research method. And finally, we evaluate the improved preemption system with before and after study. So this is research steps. We have been doing is we did preliminary study by conducting several data visualization with response time data from City of Valdosta and analyzing the data with several statistical methods to find the patterns such as seasonal effects using time series analysis. And to design the research, we contact other cities which had a similar project before, and we contact Marietta, and we thought the Marietta is the best case that we can learn. So we got the data from fire department in Marietta. And based on first 2 research steps, we determined the research methodology and the conduct before and after study. So my colleague, Xiqing, will talk about Marietta first, and I will come back for the last two steps.
So we first conducted the research with Marietta data to see how to apply into the Valdosta city. First step, we use the incident data and the source from the fire department in Marietta, combined with the GIS data with 2 different periods, with corresponding to the before and after installation of the preemption devices. So from the spatial analysis of frequency of incidents with ward and score boundaries, both of these figures shows that the region of south and east along the Interstate 75 direction has a higher accuracy of incidents compared to other regions. Next slide. However, and the average response time shows a different picture. The lower risk area of the incidents have a relatively longer response time compared to the higher risk area as we described in the previous slide. Last slide. We also implemented the fire station information with each incident on the map to better understand our data. The red plot represents the incident response time under 3 minutes. The yellow plot represents the response time in the 3 to 5 minutes. The red one is about 5 minutes. This dynamic information shows not a much closer to the fire station, a higher probability to get a quick response to the incident from the fire department. It makes sense since the fire department can assign the unit and the staff to the destination quickly with a shorter distance. Last slide. We also calculated the occupied portion of 3 categories of response time in the past decade. We found that as the number of the incidents increased in the year 2014, the percentage of the more than 5 minutes, the red bar, also increased, but decreased in the 2015 as the total number of incidents decreased. Next slide. From the data visualization and the data analysis, actually, we wanted to find the attributes that have impacts on the response time of incidents and build a model to estimate the performance of the model. And so we transferred the information of each incident from fire department into 4 groups: the location, including longitude and altitude, the fire station and dispatch the unit type, incident time and incident type. The information serial was applied to evaluate the importance of these attributes to evaluate the response time. The results shows that the top 5 indicators of response time are latitude, longitude, and unit type, and incident type of the day and incident type. Next slide. Then we built a model based on these features. We tried 3 different algorithms, but the highest accuracy of these models is only 0.7, which still needs to be improved. More attributes associated with the response time are needed to build the model. We tried the neural network to expand the feature map. However, the result is not good. And the possible reason is that the current indicators from the fire department cannot provide enough information to estimate the response time more accurately. So we may consider import the traffic conditions or much more GIS data of each incident to estimate the response time. Next slide.
Okay, now we come back to the Valdosta data. So this graph is weekly average response time. Although about 15 increase in average daily cases, we got some decrease in response time. But as we can see on the graph, before and after the red vertical line, it is not easy to say there are dramatic changes. However, if we go deep into the data, we will find the intersection improvement was pretty successful. From lessons learned from first 2 steps, we decide to import more data. So we import geospatial data to response time data by using tracking the trajectory of preemption vehicles. If you think about preemption vehicle, each incident will include each vehicle path, and this path enable us to import the GIS data to response time data. So we finally harvest many more columns for our data analysis. To mitigate uncertainty issues and check the group effects of variables, we decided to conduct a Bayesian regression model for our project. We designed and tested dozens of models with BRM, and the best fit model includes number of intersections, number of turns, distance of highway, collector, local that preemption vehicles passed. And we consider group effects on fire department number because Valdosta has 6 fire departments, and incident time, geo addresses, and 24-hour weekly day together as group. So we compare the models with leave one out cross validation and find the best model for our project. As you can see on screen, we reduce uncertainty for the analysis by using BRM compared to linear models. A graph at the right side explains when we increase the number of intersections, how much average response time will changes. So the slope of the graph explains the impact of intersection that preemption vehicles passed. And if we compare it before and after, as you can see on screen, the impact on response time of intersections has been reduced a lot. So also, if you see the right picture, we assume that preemption vehicles can save more time in case of when they make turns at intersections. Like we can think about when we drive, if my driving direction light is green, it is easy to make turn right. So we assume in that way. And also, if you compare the result of impact of distance of highways and locals, it also supported our conclusions. In case of a highway, it does not have changes or slightly worse than before, but locals has been improved a lot. So we assume the number of intersections are higher in locals and compared to highways. So that is why they show different changes. And also we conducted other approaches. This is generalized additive model, which is also a nonlinear model. It also shows the impact of number of intersections has been decreased. You can compare the slopes of purple lines on both graphs. Left side is before and right side is after. Last slide. When we import the data from GIS, we use coordinates. So if cities have complex road network like elevated road, then this approach has limitation. And we only have 3 months data after the intersection improvement. So the result can be changed a little bit later. So we need continuous monitoring and managing the data for the future work. Thank you for your attention, and my part is done, and Dr. Hojedi will lead the VSU part.
Good afternoon, and thank you, Hunjin. My name is Barry Hojedi. I am an engineering faculty at Valdosta State University, and I will provide you with an overview of the VSU part of the research related to this Valdosta Smart City, and then Dr. Lu and David, you will present their finding regarding research. Next slide, please. The overall objectives of this project was to provide opportunities for undergraduate research, which is known to be experiential learning. But in this case, as you will see, in fact, our undergraduate students, mostly sophomore students, they provided important contribution to the safety of Valdosta and this project in general. Also, they participated in community outreach and engagement with the students and other members of the community. The students, in fact, during the past 12 months, they witnessed experience from other communities, and they learned significantly by participation in this project. Next slide. Students helped to develop the survey questions and analyze the response of the survey regarding Travel Safely app and travel safety in Valdosta. And they also perform CAD and simulations and GIS analysis of some intersections at VSU. Also, we developed two courses related to traffic engineering. As Pat mentioned, we have started a new bachelor degree in engineering technology just in the fall of 2020. But for the past 30 years, we have been transferring students to Georgia Tech and many other schools in Georgia or all over the nation. Of course, 8 students actively participated in research, and only David, that is now at Georgia Tech, is available to share with you his experience. We participated in community engagement. In fact, one of my former students that received his PhD in mechanical engineering at Georgia Tech, and now he is at UCLA and doing his postdoc in mechanical engineering. As a result of this project, he has engaged 3 times, one in fall of 2020 and also in the spring of 21 and summer 21. He shared his experience with members of the communities and our students, and has been very valuable to us. And this is all because of this smart city project. Next slide. This is showing a map of North Valdosta in general, and this is 75, as you can see. And we have 2 campuses. One is the main campus on Patterson Street, and the map of it is showing in here. And then 1 mile north of VSU main campus, we have the North Campus, College of Business, Health Center, and this VMS Valdosta Middle School is there. That intersection is very important. I have been driving at this intersection for more than 18 years. And I have witnessed many situations that David will describe in a few minutes regarding close call in this area. And in fact, 2 students were assigned related to this project, and both of them really did very good job. And as a result, with the help of Pat and City of Valdosta, now we have an increased safety, as David will describe. And another intersection that we have is at the Student Union. This is a very busy intersection, and it's right in here. And next slide, I will show you the results of the analysis by some students. This is that intersection right here. The students have used CAD and also 3D printing to develop physical model, so provide awareness about the situations. And as you can see, there are basically 3 pedestrian crossing, and the measurement and analysis indicated that these 2 crossing at North Oak Street are the one that the students use significantly. And we have a lot of close call. And in fact, one of my students that is already having a travel safety app on her cell phone, she indicated to me yesterday as she was driving in this area, and another student was trying to pass the intersection. And interestingly, this student happened to have the Travel Safely app on his or her cell phone. And my student, Amy, indicated to me that she was informed through the audio signal from the Travel Safety app that there was a pedestrian ready to cross. So, and she really liked that, and she indicated to me that this is really a good thing for awareness of the drivers. And in fact, many of my students still are using and trying it on their cell phone, and they are also participating in the survey to help us to understand their view about the use of this app and encouraging them to use the app. And this is David and my other student, Dylan Boggs, that they have done a lot. And Dylan, in fact, is helping my students in my CAT class to help them to understand about these 3D printing and all-in-one 3 functions in one, both the CNC machine and also laser engraving. And David learned this device from this project. Next slide. I am very delighted that Valdosta was the very first school that became partner in research with Georgia Tech. Among all these series of community research supported by Georgia Tech, we have been selected to actively work with Georgia Tech in research, and our results speaks for itself. And based on the feedback from many members of the communities and many people that we have talked with, we consider that this experience to be very helpful to us for the progress of our engineering technology program. And we are planning to continue this kind of research. In fact, after September, students will be doing more survey and more analysis, and we are going to offer these courses in the future. Thank you for your attention. Now I pass it to Dr. Jialu.
Hey. Thank you, Dr. Hojadi, for your introduction. Well, our part of the project is to help students to apply GIS for traffic analysis in Valdosta area. Even for a small city, Valdosta actually have some traffic issue, especially around like 75, the VSU campus, downtown, and the Valdosta Mall. So our goal is to teach the students to apply GIS technology into traffic analysis using our area data. Because the GIS analysis was not used in traffic in Valdosta before the period started. So we think it's very important to get our students to review research papers and understand what GIS can do to help manage traffic. Next slide. Because of the students did such a good job, they collected and imported traffic data into the ArcGIS software, and then made maps to mark traffic based on the annual traffic account volumes. And the map on here shows where the heavy traffic areas are. And so, as you can see, most area traffic, heavy ones, are on the, downtown 75 around campus and the mall. Next slide. So in order to understand more about the hotspots of the traffic, our students collected more data on the daily traffic volume around these places, and also made graphics to show the traffic change from 12 a.m. in the early morning to midnight each day. The first hotspot, as you can see, is around 75, several ramps around 75. Okay, so next slide. Because of time constraints, I'm just not going to go to the detail about each of the maps. Okay, the next hotspot they studied was Valdosta Mall area. As you can see, they studied 3 different points near the mall area, and the north, east, the south, and the west, and they collected the traffic pattern. As you can see here, the patterns varied between different spots. And the next slide. And then they also studied the third important part was the downtown daily traffic volume. And they also picked 3 different spots, collected the traffic volume data throughout the day from early morning to midnight. As you can see, the downtown traffic volume is very different from 75. As you can see, they actually follow mostly on the basically the working class population. So the traffic peak up around 8 o'clock and 9 o'clock, and then it will subside down when people get to office, and then they started again at 4 to 5 p.m. When people start going home. The south location here has a little bit different traffic pattern. It shows the traffic, fleet traffic from 75 and to through downtown, and then go to 84 toward the East Coast, especially Savannah area, where we have a big port that's very important to us. So Valdosta is a sort of a logistic center for that reason. Okay, next slide, please. All right, so our students did a great job in the GIS analysis. Both David and Dylan were wonderful. So they also come to the conclusion that we should have our city using traffic calming device and travel safety app in order to help reducing the traffic around the hotspots in the previous GIS maps that we have identified with. So due to our time constraints, I'm not going to go to the detail. So thank you very much. I will turn the time to our wonderful student, David, next.
Thank you so much, Dr. Liu. So good afternoon, everyone. My name is David Yu, working as an undergraduate summer intern of Valdosta State University. I'll try to be concise and efficient talking about our work so that we can get time to answer all of your great questions you have. So our goal for this project was to improve safety, connectivity, and efficiency. And we focused on upgrading intersections for pedestrians, improving preemption system, promote travel safely app to the people in VSU and Valdosta community to enhance safety and connectivity by informing the drivers what they need. Next slide, please. Now, I'll show you the reason why we would need this app by simulation analysis. I used the software named Blender for it, and the purpose of simulation analysis is to find out the best way of using the Travel Safely app and to design a better safety system at intersections. These are the pictures I took on June at Valdosta Middle School, also known as VMS. Dr. Hajati suggested me to look at intersections or crosswalks at VMS since the cars driving around this school sometimes face dangerous situations. Because the sense of judgment of the students is not fully developed yet, they can just pop out of anywhere, resulting in a dangerous situation. And these concerns are the reasons why we chose VMS for simulation analysis. And now I'll show you the simulation I created showing the crosswalk of VMS, and this simulation shows the driver's point of view. Then let's take a look. All right, so I'm pretty sure some of you didn't see that student coming before facing it because your sight was blocked by a red truck in front of you. And you might have a high possibility of an accident. This is why we need a Travel Safely app. So can you go to the next slide? If we just had our eyes to sense danger so far, now we have another effective tool called Travel Safely app. And now we can be informed of the presence of pedestrians without physically looking at them. The Travel Safely app will allow the users to preempt potential accidents by alarming the drivers even at a blind spot, like the story Dr. Hajati mentioned before. Next slide. Now I'll show you the survey results for this project. According to our survey results, we have 113 respondents from our school, and those 5 intersections I have circled are most frequently used among our community. And the color of the circles indicates the street name in the pie chart. For example, the yellow circle represents Brookwood and Oak Street, and blue circle above it is Bay Tree and Oak Street. We could find out that more than 2/3 of the community use Bay Tree and Oak Street. Next slide. Then we thought if the stakeholders would likely use this app, and we found out something interesting. People who use traffic-related applications mostly don't think that the traffic in Valdosta is unsafe. More than 80% of them think it is safe, while 64% of people who don't use the app feel safe, which it has a little bit of gap. And this could be a strong evidence that there's a high possibility of changing people's mind after using Travel Safely app who thought Valdosta is not safe. Next slide. On June 23rd, we had an on-site event to introduce and explain our Travel Safely app to the stakeholders. For the audience, there were experts who work in various fields, faculty, students in VSU, and 500 people were watching our presentation live on Facebook. Next slide. That's us having presentation in Rotary Breakfast, Restaurant, and VSU Auditorium. Next slide. Now I'll show you the impact of our event. I hope you remember the simulation analysis I just showed you. And like Dr. Hajati has briefly mentioned, after we talked about the problem in Valdosta Middle School using simulation analysis, the city of Valdosta constructed a new traffic sign in the middle of the crosswalk and a new stop sign, which is much bigger so that the cars can see it better. So the left side is before the presentation and the right side is after the presentation, and you might be able to see the difference. We might have prevented numerous accidents in the future and maybe saved some lives of the students. I would like to thank City of Valdosta for responding so fast and thinking about potential for future safety of students in Valdosta Middle School. I really appreciate it. Next slide. So I had a chance to talk about our intersection progress in VSU, and I took some comments they have left for us. And all of them are faculty or students in VSU, which means they are a major stakeholders of this project. The appreciating comments were saying that the situation was real. They have expected, they have experienced the situation for real. And it needed an adjustment, and many people realized the changes that we got in Valdosta Middle School. These positive comments show that we did reflect their concerns and resolve them by taking matters into our hands. As I mentioned at the beginning of the presentation, one of our goals is to improve safety, and this might definitely contribute to enhance the safety of the students of VMS and VSU students as well. I would like to thank Smart Community Courts for giving me the opportunity to make a major contribution to the community. Thank you so much. And now I'll pass it to Patrick for wrapping up everything. Thank you so much.
Okay, so you can see that this project provided the city's many opportunities to create and sustain a smart, effective traffic control system, improve traffic flow and road safety. Hopefully we've avoided any future accidents and fatalities at some of the intersections that we talked about. Obviously, we put in the transponders in the 10 vehicles for the fire department, and you saw that in action today. This also allowed us to get involved with the Smart Cities Initiative, and it's allowed us to consider doing other things. We have some ideas with our utilities department and other areas within the city of Valdosta. And of course, it never helps. Our logo here our motto here is the city without limits. So I think that this will help develop Valdosta's reputation as a smart city, and that we are without limits. And again, it's providing an opportunity for research at both the university, Valdosta State University, and establishing this Bachelor of Science degree in engineering technology. And it's helped those folks there on Georgia Tech. So at this point, we're ready to answer any questions that you may have.
All right, thank you so much for that very detailed presentation about all the great work you've accomplished in the city of Valdosta over the last year. We have a little bit of time for audience questions, so please feel free to put any questions you have for our panelists in the chat box. At this time, we do have a few questions, so I'll go ahead and get started. The first one is, and you guys touched on this a little bit, but someone says, Henry County is also in the process of deploying similar roadside units. I understand there are two different technologies to choose from. Which one did Valdosta choose, and what's the cost of these onboard units?
I could speak to that. There are two different methodologies for doing that. One is DSRC, dedicated short range communications, which it is a radio based on the side of the road. And then you've got the vehicle portion of that. I'm not quite sure as to the DSRC portion, since we have not been using those. DSRC has had a decision made by the FCC to kind of limit its use into the future. What we are focusing on with major manufacturers is CV2X, the connected vehicle to everything. And so that is typically, it is rolled up with a connectivity and support plan that winds up being and it's tailorable to what a municipality wants to do. It's about $5,500 or so. That is the device, and 5 years of connectivity is about that price range per vehicle.
Okay, thank you so much. Some of you might have some insight into this as well. The next question is, how many states are going to be implementing this technology?
Yeah, I was going to say that's an individual community decision whether or not to implement this technology. But if anyone out there who's watching today has any questions and would like to call us, you're more than welcome to give us a contact. I'll type in here my local contact information. And again, you're welcome to give us a call and we can talk to you about it.
Great, that sounds great. Thank you so much. I think we do have time for this last question as well. You stated that you used Marietta Fire Department data in your analysis. Why? Do you think that Valdosta is similar to Marietta, or was it the only comparison data available?
I think I can answer. Oh. Yeah, I think I can answer to the question, because when we start the project, we don't have like a before and after photo data. So we want to learn from the Marietta, because Marietta already have like a before and after study. So that's why we work on the Marietta. Actually, the conclusion is Marietta and Valdosta shows a little bit different, but still it helps us to design the research. So that's why we start from the Marietta.
All righty, thank you so much. We don't have any further questions remaining in the chat, but as Pat mentioned, he'll be happy to have any further discussion with you guys, or you can always contact us at the partnership and we'd be happy to connect you. Thank you all so much for joining us today. Please continue to monitor our website, penngeorgia.org, for upcoming Smarter Together webinar information. We want to especially encourage you to attend the last final presentation for our Georgia Smart 2020 communities on October 14th, which will feature the City of Savannah's project. Thank you, and we hope to see you all soon.
Thank you.